In this video, we're going to look at writing formulae for ionic compounds that contain molecular ions. It's very similar to what we've done before. We will be using our swap and drop method. We just need to be a little bit more careful with these types of examples. And again, you will need your booklet, some file paper, and your periodic table. So if you don't have those out, maybe pause the video, get those out, and then continue on. So I want you to turn to page 6 of your notes, and as I said, in this video we're going to look at examples that contain molecular ions. So turn to page 6, the bottom half, which says formulae of compounds containing molecular ions. So first of all, it's thinking what are molecular ions and where do we find them? So molecular ions are simply ions, which we know are charged particles, which have more than one atom in them. So they're not simple ions that are just like, say, Cl- or Mg2+. These ions have more than one atom. Or you can think about them as being molecules that have become charged, have become ions. Okay, and molecules are substances which contain more than one atom bonded together. They can be the same or different. And essentially, there's nothing different about what we're doing. We just need to be a little bit careful. And where we use molecular ions and where we are swapping down a number greater than 1, then we need to use brackets. But we'll see those in our examples. So let's have a look at some molecular ions, because the most common mistake for people to do is that they either forget to include the subscript number in the formula, or they use that number as the valency. And we spent a wee bit of time doing this in our first lesson in this topic, having a look at what's the valency and what is the formula. So here are two molecular ions. The one on the left is the sulfate ion, and you would find that on the back of your periodic table. These ions do not exist on the front of the periodic table because they contain more than one type of atom, so they're going to be, you find them on the back of the periodic table. We'll have a look at that in a second. So it's really about working out, well, what is the formula and what is the charge, therefore the valency. So if we have a look at the sulfate ion, the formula of the ion is SO4 2-. So this SO4 part is the formula. So at the point in our method where we have to write down the formula of the ion, we would write down SO4 and we would ignore the charge. What about the rest of what's written there? Well, you're told there that the charge is 2-. So this is the charge. So what is in the top right-hand corner is the charge. And from that, I get the valency. What do you think the valency is of my sulfate ion? It's going to be 2. Okay, so the formula is SO4, the charge is 2-, so that means this has a valency of 2. Let's have a look at another example. This example here is the nitrate ion. Again, you would find that on the back of your periodic table. And let's have a look at what is what. So what do you think is the formula? Well, the formula is NO3. The formula is going to be everything apart from the charge, including the little numbers at the bottom. And if you want to write that down, you can do. The formula is everything apart from the charge and does include the little numbers at the bottom. So that's the formula. That's what I would write down for the formula. And this is the charge. From that, I get my valency, because remember, the third way of finding the valency is that we get it from the charge on an ion. So if an ion is charged, then the valency will be corresponding to the charge. Rather than writing minus, we write that this has a valency of 1. So if it's just minus or plus in the formula, then the valency is equal to 1. And it's really important that you know the difference between what is the formula, what is the charge, before we then go to use these for working out what the formula of our ionic compound containing these ions are. So just be really careful about the ending of a compound so you know whether we're talking about molecular ions or whether we're talking about just simple ions. So for example, if we had sodium sulfide, that would mean that the compound contains sodium and sulfur only. But sulfate would mean that there's another element present, and that is oxygen. And you would have learned that at an earlier stage. So if something ends in ATE, it suggests that there's oxygen there as well as your other elements. So sulfate is sulfur and oxygen. Nitrate is nitrogen and oxygen, as we've seen here. There's other things like carbonate, it would be carbon and oxygen. But if it ends in IDE, then it's generally just a simple ion that has gone from, say, chlorine to chloride, sulfur to sulfide, and means it doesn't have oxygen in it. There's one exception to that, and that's hydroxide, but we'll have a look at that now. So what I'd like you to do is get your periodic table out and look at the back of the periodic table, and we'll see some of these ions. So this is what the back of your periodic table should look like, although it may not be coloured. And what I'd like to do is zoom in on this very back part. If you folded it over, this will be the very back page. And we'll have a wee look at where we would find some of our molecular ions. So if you have a look at the positive ions, there's one molecular ion there, and that is the ammonium ion, NH4+. So I've just written that out again underneath the table. So what that would mean if I was using this and trying to work out the formula of a compound containing this, remember I would be writing down NH4 is my formula, and then the valency would be equal to 1. I get the valency from the charge. More commonly used are some of these negative ions. Now, butanoate, ethanoate, methanoate, and so on, they're generally used in 5th form in your Unit 2 chemistry. But some of the really common ones that they will use this year will be things like hydroxide, if I highlight that, nitrate, and sulfate. Just be really careful. Another one is hydrogen carbonate and carbonate itself. So these are the most commonly used ones in Form 4. So you'll see there that you're given the formula, including the charge. And these are quite squished together in terms of the numbers, but it's just about working out, well, what am I using for each part? So if we look at carbonate here, okay, we'll write that a bit bigger. CO3, 2 minus. That's how we say the formula. CO3, 2 minus. This part here would be your formula. And this 2 minus you would use for your valency. And the valency is equal to 2. So let's have a look at some examples of writing the formula of compounds containing these ions. So let's have a look at page 7, and there's 2 worked examples here that we're going to have a look at. So we're following a very, very similar method to what we used before, but there's an extra step of using brackets if we need to, but we'll come on to that in a second. So step number 1, just as it was before, convert the compound name to symbols. Again, I've written my name out again in 2 different colours, and I'm going to work directly underneath that. So we've got calcium, first of all, which is just an element. So all I need to write here is Ca, the symbol for the element. Hydroxide then is one of our molecular ions, and it appears on the back of the periodic table. Have a look at the back of your periodic table there, and you'll see it appears as OH minus. Okay, for the molecular ion, as it says in italics here, write down everything except the charge. So I don't want to include the charge here, so no charge at this point. So what am I looking at here? Well, I'm just looking at my OH. If there was any little numbers down at the bottom, I would include them, but in this case, there's no numbers down at the bottom, and I don't want to include the charge. So hydroxide here, I'll just write OH, but do not include the charge. Second thing is work out the valencies. So for calcium, have a look now at the front of the periodic table. So calcium is in group 2, so it has a valency of 2, just as we were doing with our slightly more simple examples last week. So make sure you can see that from the periodic table. Calcium is in group 2, so it has a valency of 2, and I write that in the top right-hand corner for my working out. Then hydroxide, let's have a think about its valency. So its formula is OH. But if have a look at the charge, remember the third way of finding a valency is that it's equivalent to the charge on an ion. So if this is OH minus, then my valency is equal to 1. And it's sometimes worthwhile working that out at the start of your working out. So I'm going to write that in the top left-hand corner so that these valencies are beside each other. Next part is cancel down if possible, and this is an important step just as we were doing the last time round. Can we cancel this down? The ratio is 2 to 1. Is there any simpler ratio that I could use? No, there's not, so we cannot cancel this down. Next step then is put brackets around the molecular ion if you're going to be swapping down a number. Okay, so let's have a think about what we're going to be doing here. We're going to be swapping, and you don't need to write this in necessarily, we're going to be swapping down a 2 from the calcium to our hydroxide ion. So we are swapping down a number that is not 1, and so therefore I do need to include brackets. So let me show you what I mean by this. So with calcium, I don't need brackets around it because it's just a normal element. There's just one atom there. But the hydroxide, I need to put brackets around it, and you'll see why in a second. So put brackets around the whole formula, and then we'll rewrite our valency. Okay. The next step then is to swap and drop and ignore the ones. It's easier just to ignore the ones in the same process here, because we've got enough steps as it is, essentially. So let's have a think what we would have. We would have Ca, and then we would be swapping down a 1, but that's going to be ignored anyway, so I'm not going to include that. If you would prefer to include it, then you can do, but then you'll end up leaving it out anyway. Okay, so then I would open up my brackets and write OH, close the brackets again, and the little 2 goes outside the brackets down at the bottom. Remember, swap and drop, and you're removing the little circles as well. Now it says here, brackets are essential in this example to show that the 2 you have swapped down from calcium applies to the whole hydroxide ion. And I'm going to show you on a blank slide why this is important. So let's look first of all at the correct formula. So the correct formula of calcium hydroxide is Ca brackets OH, close your brackets, 2. What does that actually mean in terms of the number of atoms? And this will be important later on in our topic. It means that we have 1 calcium because there's no number after the calcium. It means that we have 2 oxygens. So 2 oxygens. Why is that? Well, it's because I've got 1 in the bracket, and this number 2 multiplies that by 2. So I have a total of 2 oxygens. And I also have 2 hydrogens. 1 in the bracket multiplied by 2 gives me 2 hydrogens. But let's have a look at the incorrect formula if I didn't use brackets. How many calciums do I have? I have 1. How many oxygens do I have? I only have 1 because there's no number after it. And that 2 only applies to the hydrogen. So you can see that this incorrect formula, without the use of brackets, would give me the wrong number of atoms of oxygen. So it's so important with these molecular ions that we use brackets if we are swapping down a number. If we are swapping a 1 down, we don't need to include the brackets because that 1 will just disappear anyway. And we'll have a look at another example now to see that. So go back to page 7, and the example at the bottom of the page is magnesium sulfate. So we know by the end of it that it's not just a simple case of sulfur. We've got sulfur and oxygen. So this is a molecular ion that we'll need to use looking at the back of the periodic table. So the first thing is convert the compound name to formula. So let me just show you in the periodic table where we're going to get that from. So first of all, magnesium. So we can see magnesium is just an element on the front of the periodic table. So it's Mg, and it's in group 2, so it's going to have a valency of 2. But what about the sulfate? Well, we know it's not just sulfur, because otherwise that would be sulfide, but it's sulfate, which is one of your most commonly used molecular ions. So have a look at the back of your periodic table. So if you have a look at the back of your periodic table, just be really careful because at the bottom there's sulfate and then sulfite. Sulfite has 1 less oxygen in it, so just be really careful. So there it is there in the negative ions. If I zoom in, okay, this is your formula here. So it's SO4 with a charge of 2-. So normally the way we say it is the whole formula first, which are the letters and the numbers at the bottom. And then we say the charge at the end. So it's SO4, 2-. So let's go back to our example. So let's go back to the bottom of page 7 and fill in our working out. So we've got magnesium sulfate. Again, I've just written these so I can work out, do my working out directly underneath. So the first step is convert the compound name to the formula. So magnesium is Mg. Sulfate then, if you have a look at the back of your periodic table, is SO4, 2 minus. So what I'm asking you to write down at this point is just the formula, is everything except the charge. So that's the letters and the numbers at the bottom. Okay, so the letters and the number at the bottom, that's part of the formula. And I know I'm saying this a few times, but people commonly make mistakes with this. So I'm just writing down SO4 at this stage. Okay, so make sure you've got the S, make sure you've got the O, and make sure you've got the little 4 at the bottom, but not the charge. Next part then is work out the valencies, and as we saw from our periodic table, magnesium is in group 2, so has a valency of 2. Sulfate then is SO4, but its charge is 2 minus, so that means the valency is 2. And if you want, you can write that working out somewhere on your page as well. So the valency of sulfate is 2. This is a really important step. Sometimes people forget this, particular with molecular ions, because you've got lots else to think about. But you must remember to cancel down your valencies if possible. So here our valencies are in a ratio 2 to 2. Could that be any simpler? You're asking yourself, is there a number I could divide both of those by to simplify it down? So yes, there is. In this case, both of these numbers divide by 2. And what you would get if you divided both of them by 2 is 1 to 1. So your valency then, your cancelled down valency of magnesium is 1, and the same with sulfate. So your ratio now is 1 to 1. The next part is put brackets around the molecular ion, so our sulfate ion, if swapping down a number. Are we going to be swapping down a number at this point that is greater than 1? No, we're not. Because what happens here is that we're going to ignore the ones. Therefore, if there's no number outside the bracket, then we don't need to include it. And that's why we do it in this way, in this order. So we don't need brackets in this case because there's not going to be any number swapping down because we end up ignoring the ones. So we essentially swap and drop and ignore the ones. And what we end up with is MgSO4. Remember to write that with no spaces in between it. So that's my final formula, and I don't need brackets in this because essentially what would happen is if we included brackets, we would end up with, okay, Mg1, SO4, 1, we would swap and drop and ignore the ones because ones aren't included in formulas. So we would end up with Mg brackets SO4. There's no number after it, and therefore there's no need for the bracket if there's no numbers afterwards. Okay, what I'd like you to do now is turn to page 9 in your booklet, and I would like you to try examples 21 to 30. So you can see here 21, you should have done 1 to 20 in our previous lesson. 21 starts with magnesium hydroxide, and the last one I want you to do is zinc hydrogen carbonate. I just want you to do these 10 examples, 21 to 30. Just in case we make any mistakes as we go along, I don't want you to do them all wrong. So what I'll do is I'll check your work and then I'll get you to do the rest after that. So just as before, I want you to do your working out on file paper and then just write the final answer in your booklet. But I want you to submit both things to the assignment on Teams. I want you to submit your working out and your final answers in your booklet and submit that to the assignment on Teams as a Word document so that I can mark it. So let me show you how to set out your first example and how to do example 21. So again, this working out should be done on file paper and you should set it out as follows so that I can see your working out, so that if you get your final answer wrong, I can try and point you in the direction of where you've gone wrong. So you can continue on this on your same file paper that you were working on the previous easier examples. So you would write out the name of your compound. It's really important to do that. So when you're looking back, you can see what example you were doing. So this is magnesium hydroxide. So first step is convert to the symbols. So magnesium is just Mg. Hydroxide is on the back of the periodic table. It's one of your molecular ions. It does end in IDE. It's the one exception that it does end in IDE but still contains oxygen. So if you have a look at the back of your periodic table, it appears as OH minus. Remember, at this point, I only want to write down the formula, so essentially everything apart from the charge. So I would write down OH. Next step is to work out your valencies. So magnesium is in group 2 of the periodic table, so it has a valency of 2. Hydroxide has a charge of minus or -1, so its valency is 1 also. Next step, you have to check, and again, please use the method in your notes to keep yourself right. The next step is you need to ask yourself, can I cancel down these valencies? At the minute, they're in a ratio 2 to 1. Can you cancel that down any further? No, you can't, so it's going to stay just as this. Next part then is, if you're going to be swapping down a number to your molecular ion, then you must use brackets. So have a look at this example. You're going to be swapping down a 2 from your magnesium to your hydroxide and a 1 the other direction. So this time I will need to include brackets. So essentially, if the valency on the other element is 2 or more, then you're going to need brackets around your molecular ion. So I'm going to put brackets around my OH here, and make sure you don't include the valency in the brackets. Then we're ready to do our swap and drop, and remember we ignore the ones at the same time. But if you include the ones, that's fine, just remember to leave them out of your final formula. Okay, so let's have a look at this example. It's going to be Mg, and then I'm swapping down a 1 from my hydroxide, so I don't include that. And then it will be, open your brackets, OH, close your brackets, and then the little 2 outside the brackets. So the number that you're swapping down from your other element, that goes outside the brackets. And that shows me that that 2 that I've swapped down applies to everything from my molecular ion, everything that's in the brackets. So that should be your final answer, and then you can write that into your booklet. So continue on with examples 22 to 30 now, to give yourself a little bit of practice in this. These are harder, so make sure you follow the steps very, very carefully, step by step. What I suggest you do is try 22, 23 and 24 now. And pause the video while you do that. Give that a go yourself. It's important that you try these yourself. And then what I'll do is I'll go through those 3 examples so that you can check if you're doing these correctly and fix it if you're going wrong. And then you can carry on with the rest yourself. So make sure you've had a go at these yourself before playing the video so that you can try it and then check if you're doing it correctly. So number 22 is calcium sulfate. So with calcium, you're writing down Ca. With sulfate, it appears in the back of your periodic table as SO4 2-. So at this point, I'm writing down SO4, not including the 2-. Then we need to work out our valencies. Calcium is in group 2, so has a valency of 2. Sulfate has a charge of 2-, so its valency is 2. Then you ask yourself, can I cancel these down? And this is in a ratio 2 to 2, which is the same thing as 1 to 1. Again, you're asking yourself, can I divide both of these numbers by something to make them a simpler ratio? And they both divide by 2. Okay, next step is put brackets around your molecular ion if you're going to be swapping a number down to it. But I'm swapping down 1, which is going to be ignored. So therefore, I don't need brackets. So essentially, I'm just swapping and dropping. But remember, ignore your ones as you go because they're not included in the formula. So your answer should just be CaSO4. Number 23 is then aluminium nitrate. So the first step is to write down your symbols. Aluminium is Al, and then nitrate on the back of your periodic table is NO3-. So at this stage, I write down everything except the charge. So that's just NO3. So make sure you include that little 3. Next step is to work out your valencies. Aluminium is in group 3, so it has a valency of 3. Nitrate has a charge of -, and so its valency is 1. Next step is to cancel down if possible. So our ratio at the minute of our valencies is 3 to 1. Is there a number I can divide both of these valencies by to make that ratio simpler? No, there's not, so I leave it as it is. The next step is to put brackets around your molecular ion if you're going to be swapping down a number. So let's look at what our swap and drop will be. I'm going to be swapping down a 3 to my nitrate ion. So yes, in this case, I do need brackets. So I just write them around my nitrate ion, the NO3. I don't include the little valency inside the brackets because that's going to be swapped down. Next step is to swap and drop but ignore your ones. So it would be AL1, but we just leave ones out of the formula, so you can just ignore them at this point. Then I would write my brackets, NO3, close your brackets, and then the little 3 goes outside the brackets, and that's the 3 that you've swapped down from aluminium. So notice how your final answer of number 23 has 2 3s in it. The 3 inside the bracket is because your original formula of the nitrate ion has a 3 as part of it. There's 3 oxygens in a nitrate ion. And then the second 3 comes from your valency that you've swapped down from aluminium. So make sure that that answer is fully correct and that you copy it in accurately to your booklet. Then number 24 is magnesium sulfate, which we actually did as one of our worked examples, but let's do it quickly now. So magnesium is Mg. Sulfate on the back of the periodic table is SO4 2-. So sulfate is SO4, and we ignore the charge at this point. Next step, write your valencies. Well, magnesium is in group 2, so has a valency of 2. Sulfate has a charge of 2-, so it has a valency of 2. You ask yourself, can you cancel these down at all? And yes, you can. This is 2 to 2, which is the same as 1 to 1, dividing both of those valencies by 2. Next step is put brackets round your molecular ion if you're going to be swapping down a number. But in this case, we're just swapping ones, which are going to be ignored. So therefore, I don't need brackets. And my final answer is just MgSO4, because those ones that I swap down will be ignored. So your final answer is MgSO4. So what I'd like you to do now is to finish examples 25 to 30, just 6 more, and then submit those to Teams as a Word document, both your working out and your final answers in your booklet, so that I can check both your working out is correct and that your final answers are correct in your booklet, so that you have accurate information in your notes. If you have any problems along the way, please do just put a message in Teams and just tag me in it, and I'll pick those up during the lesson to help you as you go along. But just one final encouragement to follow that step-by-step method in your notes, and just be really careful, particularly with your use of brackets and making sure you're including all the numbers in the formula and so on.